basics of inequalities. We're going to talk about graphing and what it means to be a solution for an inequality. So we just talked about solving equations. An equation has one solution. If x equals 4, that is the solution. An inequality has a bunch of solutions. It has many solutions, actually infinitely many solutions. An inequality shows the relationship between two expressions. It says that one expression is bigger or smaller than the other expression. So when we talk about this symbol, we describe that as less than because we would say that x is less than, I'm just going to write 4, but it could really be any number on that side, but that's just how we read that, going in that direction. X is less than 4, or x is less than or equal to 4, or x is greater than 4, or x is greater than or equal to 4. So when I say less than, a less than symbol, it's pointing that direction because it's talking about this, the relationship between this side and this side. That side is less than that side. Each of these has just different phrases that might mean the same thing. So if I say you have to be 42 inches or under to ride a ride, I guess that's not a typical condition, but let's say you have to be under 42 inches to ride a ride. That means you have to be less than 42 inches to ride that ride. So each of these words or phrases just is kind of a synonym to the phrase above it. So under, below, fewer than, those all mean less than. At most, at maximum, or no more than all mean less than or equal to. Or equal to means it could include that number. So if I say you have to be at most 42 inches to ride a ride, that means you could be 42 inches or anything less. Or at a maximum, or no more than. It goes right up until that number. It includes that number. Or it could be anything less. Phrases that mean the same thing as greater than could be more than, above, exceeds, or over. And then the same thinking as less than or equal to. We have greater than or equal to, so if it's at least, I'm going to keep using that example of 42 inches. If you have to be at least 42 inches to ride a ride, that is a more common example. You have to be at least 42 inches to ride a ride. You could be 42 inches, or you could be something greater than that, or at a minimum, or no less than. It can't be anything less than that, but it could be equal to 42. When we're graphing inequalities, an open circle means that that value is not included. We put an open circle there to imply that it starts there, but it's everything bigger than that, but we don't shade in that circle. If you shade in that circle, that should really say 2, or I guess that should say 3. Let's change that one to 3 because that's what the graph says. When we shade in that circle, we're saying it could be 3 or anything bigger than that. So a filled in circle means that's included, and that has the or equal to part of that symbol. So x is less than 5. We have an open circle at 5, and it's everything less than that. 0, 1, 2, 3, all the decimals in between, everything smaller than 5, but not including 5. It's got to be strictly less than 5. X is less than or equal to 6 means we include 6. It could be equal to 6, or it could be anything smaller than that. So I'm trying to graph this. X is less than 4. I put an open circle at 4 and an arrow going to the left of 4, implying that it could be anything less than 4. X is greater than or equal to 0. It could be equal to 0, so I fill in a circle there, and then draw an arrow going to the right. It could be anything greater than or equal to 0. When we write an inequality, we can write it in either direction. So if we flip the inequality, it remains true. I see it more intuitively with the variable on the left side, just because that's how I read it. I think about x as all the numbers that are bigger than 8 here. It's everything bigger than 8 that's shaded there. It's not including 8, that's an empty circle, or it's an open circle, so we don't put the line underneath, so it's strictly x is bigger than 8. We could also phrase it the opposite way, though. We could say 8 is less than all of our values of x. Same thing here. Now we have a filled in circle, and we're shading all the numbers smaller than or equal to 3, so x is less than or equal to 3. Or we could flip the entire inequality and say that 3 is greater than or equal to x. So you're allowed to flip these, but you also have to flip the inequality symbol, so keep that true. All right, we're going to translate each of these into an inequality, and we're going to pick some possible solutions or values that make sense, that really are being described by that sentence. So you must be at least 40 inches to ride this ride. You could be 40 inches. You could be 40.5 inches. You could be 41. You have to be 40 or more. So it could be a decimal that's slightly above that. It could be exactly that number or anything bigger. So we're going to write that as x is greater than or equal to 40. Or, flipping that, 40 is less than or equal to the value of x. The value of x there is your height. Students may check out at most 4 books. So you can check out at most 4 books. You can check out 4 books. You can't check out more than that. So you can check out 3, you can check out 2, you can check out 0. So we're going to talk about x as being numbers that are less than or equal to 4. Part of that doesn't quite make sense because you can't really check out negative books. But if we're talking about that as an inequality, we'd write that as at most. I guess the best way to write that would really be that x is in between these two numbers. That's called a compound inequality. You'll learn about that next year where there's something on either side. We could also flip this and say that 4 is greater than or equal to the number of books that you check out. Children 11 and under eat for free. So you could be 11 and eat for free, you could be 10 and eat for free, you could be 2 and eat for free, anything 11 or smaller. So x is less than or equal to 11, or 11 is greater than or equal to x, which is the age of the children. Suitcases that exceed 35 pounds will pay a fine. So it has to exceed 35. So 35 actually doesn't work there. It's got to be greater than 35. So it can't be exactly 35. It could be 35.5. That's a little bit bigger than 35. It could be 36. It could be 100 pounds. Anything bigger than 35, but not including 35. So we're going to say x is greater than 35. It's not greater than or equal to, just greater than. Or we could flip it and say that 35 is less than the weight of the suitcase. All right, now we're going to pick out solutions just from the inequality and from the graph. So x is greater than 4. We're thinking about all the numbers that are bigger than 4. 4 is not included in that. 4 is not greater than 4. So 4.2 works, 9 works. None of these other ones work because they are not greater than 4. X is less than or equal to -1. Well, it's going to start at -1 because it could equal -1. Or it's going to be anything that's less than that, so all the negative ones. Doesn't include every negative number. -0.5 would not be included. That's a little bit bigger than -1. I just read these so much better going the opposite way, so I'm going to flip this. I'm going to write this as x is greater than or equal to -10. I'd recommend you write it, just rewriting it like that. If you want to, you could read it like this. You could say -10 is less than or equal to all of our values of x. I just think of this better. So I'm thinking about x is greater than or equal to -10. All the numbers greater than or equal to -10. So anything positive is going to be bigger than a negative, and -5 is also greater than or equal to -10. Now we're just picking from the number line. Anything that's shaded in by this number line, or by that arrow really. So anything bigger than 2. 2 is not included there. It's an open circle, so 2 is not included, but 2.001, that's slightly bigger. That's right there. 8 is off the number line, that's somewhere over here. But that is going to be covered by that arrow. Anything bigger than 2. This is anything less than or equal to 16. So 16 is going to be included. Anything smaller, 15, 5, somewhere off in that direction, is also included in that arrow. X is less than -11. All the numbers smaller than -11, that's just -20. -11 is not included because it's an open circle. All right, now we're going to put it all together with this one example. On highways, drivers sometimes see this sign, minimum speed of 40. So it's saying you have to travel at least 40 miles an hour. Typically, you'll see a speed limit, which means you have to go that speed or less. But if we're talking about a minimum speed, we would say that x needs to be greater than or equal to 40, or 40 has to be less than or equal to your speed. So drivers must drive. I'm just going to say drive at least 40 miles an hour. Drive at least 40 miles an hour. That implies you could drive 40 or faster. All right, I'm going to write a few numbers on this number line. Doesn't really matter where you put your numbers. I know I'm going to have a filled in circle at 40. You could travel 40 miles an hour, or you can go faster. anything faster than 40, which is going to include 40, 45, 55, and 70. I'm just going to keep going through the U-try. If you need this, use it. I might pause it and then try it first and see how you do. We're going to write that inequality in two different ways. So I'm going to write it with the x first and then with the number first. So x is all the numbers smaller than or equal to -3, or flipping this, bringing the -3 to that side, bringing the x to this side, and flipping the inequality symbol. -3 is greater than or equal to x. We're going to translate this sentence into an inequality. Michelle wants to sell more than 10 boxes of cookies. Strictly more. She doesn't want to sell 10. She wants to sell more than 10. X has to be bigger than 10. I'm going to flip number 3 just so I can read it easier. I flip the positions of the x and the -5, and you flip the inequality symbol. I especially like this when we're graphing it because that's basically the end of the arrow. That's the direction the arrow is going to go. X is greater than -5. It's going off in that direction. It's all the numbers bigger than -5. X is less than 12. All the numbers smaller than 12. Anything negative. 0 is smaller than 12. 12 is not less than 12. Which numbers are not solutions? So we're thinking about anything that's not covered by this arrow. So -3 is out. That is covered by the arrow. -2 is out. That's covered by the arrow. -1. Is that a solution? If it were a solution, that would be filled in. So -1 is actually not a solution, even though that's where we start. It's not a solution because it's not a filled-in circle. And then anything to the right is also not going to be a solution. Last one, we're going to write that inequality in two different ways. It's kind of like this one. X is greater than 5, or flipping that, 5 is less than x. Alright, that feels like a very thorough review of inequalities. We're going to get to solving inequalities. So that's basically what we were doing with equations, where we had to solve multi-step and variables on both sides. But then we're going to boil it down to finding graphs of those or solutions from those after we actually solve.